All right, so let me bring up a couple pictures. And it wasn't under worksheets. Where did I put it? I might have put it under honors. Oops. And chapter 1, and I think, yep, section 1.7. There we go. See all these different things that we have? The first one, and if I know what I got to do. Yeah, just do that. There we go. Took a while, but I got there. All right. So what you have to do is just be able to identify these shapes that I'm going to show you today. Okay, it's very simple. If you want to try to draw this, feel free to draw it if you want. It's not just a circle, though. It's three-dimensional. All right. So it actually doesn't just have a, go this way and this way. It actually goes out. You follow me? That's the third dimension. All right. So you've seen this before. It looks like a ball, doesn't it? All right. But we don't call it a ball. We call it in geometry. What do you think we call it? Anybody? A sphere. Right. You've heard that before. It's kind of a weird, the sph. We don't have too many of those in the English language, but it's sphere. It's kind of tongue-tying thing, but it's called a sphere. All right. And a sphere has a center, just like a circle does. I mean, a sphere is very similar to a circle, isn't it? Because it is circular. Okay. But it goes in all directions. It doesn't just go from one point out here, out here, out here. It also goes towards you. It goes in all directions. And that is a sphere. It also has a center, right? The center of the sphere. It also has this. From the center to any point on the sphere itself, there's a big hint right there. It even gives you an R. What do you think you call that? You call it the radius. That's right. So you have the radius of the sphere. There's a lot more to learn about a sphere. And maybe later on, towards the end of the book, we're going to learn how to do some stuff with this, like find the surface area of the sphere, find the volume of the sphere, and things like that. Okay, but today we're not. Okay, we're not going to get that into it today. I just want you to be able to look at it and be able to identify it. Don't just write ball. Don't write basketball or soccer ball. Okay, it's a what? Sphere. It's a sphere. All right, let's do another one. All right, come on. Come on, there we go. And we've got this. What does this kind of look like?
A cone.
It is a cone. Like if you turn it upside down, right? It looks like if you get like a snow cone thing, or you get a sugar cone. Probably not one of those cones where it's flat on the bottom where you can sit on it, right? But it's like a, what do you call that other sugar cone that's really good? Like a waffle cone or something like that? Yeah, it comes to a point at the bottom. So that's what this basically is. It's a cone. So if I wanted to be really precise about this, I would call this I'll tell you this in a second, a right circular cone. Okay, why is it right? Well, I'm glad you asked. I'll show you. So if you went from the very top of it straight down here, okay, and then, well, I didn't go far enough. Let's try this again. I'll tell you what I'll do is this so I know. So it should go to there. All right, you get the idea? I'll tell you what I'll do. I'll just put this thing right there. Yeah, that box means it's right. So if I go from the top of this cone straight down, okay, it's going to hit right in the middle. What kind of a shape is the bottom of this cone going to be? It's a circle, right? Because it's a right circular cone. All right, so it's a right circular cone. Sometimes they'll draw it like this. They'll put like a dotted line. You ever see that? Okay, why do they do that? What's up the dotted line? Yeah, it's like the back of it. Okay, you can't really see it, right here. But again, it is three-dimensional, so it does have like a back to it, I guess. Right now, this doesn't look like a perfect circle, because again, it's three-dimensional. And we write something that's three-dimensional and we write it in 2 dimensions, right? Just like a board, just has a height and a width. If you do that, sometimes they take that thing and they kind of slant it to make it look like it's three-dimensional. Does that make sense? All right, so that's why this kind of looks more like a football than a real circle. It's just because they kind of slant it a little bit to make it look as three-dimensional as it could, on a 2-dimensional piece of paper or a board or a screen or something like that, okay? So the bottom of it is a circle, so it's a right, or it's circular, and it's right. Now, what makes it a cone? Well, what it does, if you take that circle and you take all the points and you connect it to one point above it, okay, that makes it a cone, all right? So anything that starts as a certain shape, you could even have like a weird looking shape. I don't know if I could draw anything, but if you can have something that looks like this, right? But if all the sides go up to one point, not too good, not a very nice straight line, but you get the idea. Even if you have some kind of crazy shape, but if all the sides went up to one point and they met at one point, we would call this a cone. That's a pretty ugly cone, but that would be a cone. Trent? Did you start recording yet? I did. All right, so that would be considered a cone. That's a very ugly cone, but you get the idea. You with me on that? Okay, so a cone, what's it do? It's a circular cone has a circle at the bottom, right? And then all the sides of that cone, they come up to a what at the top? To a point. Everybody got it? They come up to a point. That's considered to be a cone, all right? You could also consider it, and we're going to do this in a second, you could also consider it a pyramid, all right? So you know the pyramids in Egypt, right? They're like the most famous pyramids. There's other pyramids in the world, but the ones in Egypt are the ones that are super famous, okay, the Egyptian pyramids. They all come up to a point, all right? But some of them are square at the bottom or they're rectangular at the bottom and they come up to a point. When you have that, they usually use the word pyramid for that, okay? If it's a circle, they usually use the word cone, but a pyramid, it's the same idea because all the sides come up to a point, but usually when they're straight sides, we would call it a pyramid, all right? So let's find one that looks like that. Yes, sir.
What would, like an hourglass shape be called? Where it's like two kind of cones stacked on top of each other?
I don't know if there is a name for something like that. If there is, I don't know what it is. But it's kind of parabolic. You'll learn that when you get to Algebra 2. You'll learn about parabolas. So that would be kind of parabolic, but it's three-dimensional. So I'm not really sure what the word for that would be, if there is a word. There might be. Let's do the pyramid. I was going to go cylinder, but let's go pyramid since we just talked about it, okay? And let's scooch this up a little bit.
He said yes.
And let's grab this again. There we go. All right. So this thing right here, this is what I was just talking about as far as a pyramid. All right. Look at the bottom. The bottom is a certain shape, but look at the sides. All the sides go up and they meet where? At a point. They meet at a point. Okay. Now, if that point is directly above the center of that object, okay, then it would be a right, whatever it is. Now, on this one, you could call it a rectangular pyramid. Why would I call it rectangular? It looks like there's triangles here. Why would I call it rectangular pyramid? Rosalind? Let's help her. That's what you're going to say, though, right? Yeah, because the bottom is a rectangle. Okay, the bottom's a rectangle. It goes up to a point, so we would call it a right if this is right in the middle, because they don't really show it, do they? But if they did, if they went from here like straight down and hit right at the middle. Everybody see that? And if this went to here, like, oops, missed it. Let's try it again. There we go. All right, and if you had a little right angle thingy here, that would be a right rectangular pyramid. You got it? Tell you the truth, I'm okay if you just say it's a pyramid. All right? Notice what it does. It goes to a point. That's very important because in a bit, we're going to see some things that the sides don't go up to a point, that the sides just go straight up. All right? That's not what this is. A pyramid or a cone, all the sides go up and they meet at one point. Everybody got it? All right, let's do another one. Let's do this one. Since we're talking about pyramids. Oops, forgot to scooch down. Now I got to do this again. Now, you guys are up close, could have read it. You probably already know what this is. So now, this is a pyramid as well, isn't it? How do you know just by looking at it super quick that it's a pyramid? All the sides come and meet at a point right up here, okay? But what kind of pyramid? Like this one, I called a rectangular, let's write that down, rectangular pyramid, okay? What am I going to call this one? This is also a pyramid. Makai, help me out. Say it again, I didn't hear you. Right, it's a hexagon, right? So we call it, the other one we said rectangular, right? So what are we going to call this? Well, this is a little bit different. It's hexagon, but it's a hexagonal is how we would pronounce it. Hexagonal. And then what is it again? It's a pyramid. You're going to name your kid that? Is that what you said? Yeah, it's a pretty crazy name. Call him Hex for short, right? Okay. So watch. 1, 2, 3, 4, 5, 6 sides to it. So it's a hexagonal pyramid. And again, if I drew a line straight down to the middle and it came over here at a right angle, we would call this a hexagonal or a right hexagonal pyramid. Now, there are pyramids that aren't right pyramids, and there are cones that are not right cones. I don't have one. I don't think I do. Well, actually, I have one that's not a cone, but it's something else. We'll wait till we get to that, all right? So let's do rectangle. How do you spell it? R-E-C, and then tangle, T-A-N-G-L-E. Like that movie, yeah. All right, let's do another one. Let's do this. You might know what this is off the top of your head. I don't know. But is this a cone? Why not? That's right. It doesn't come to a point. Yes. What's that? Okay. So I heard it. I heard somebody say it. It is a cylinder. Okay. So look on your paper for the homework. Okay. All right. So we call it a cylinder. Now watch. Look at the sides. They go completely straight up and down. So if I was to do this, if I was to put a dot in the middle, and I was to come right to here, I should do a different color, shouldn't I? Since let's go blue. Yes, I will. Yes, I did. All right. Today's what day? It is Wednesday. Whoops. Well, anyway, it's supposed to hit right there. Good enough. Close enough for us. So if I did this, I would call this, listen. If I did this and I put a right angle thing right here, that means these sides would go completely straight up. They don't slant. You follow me on that? They go straight up. I would call this a right cylinder. Now, there are cylinders that are not right cylinders. Sometimes, instead of going straight up, it might go like this. It might slant a little bit. Okay? Most of the things we see, like this thing right here, some kind of speaker thing, this would be considered a cylinder. All right? It's a right cylinder. Look at the bottom of it. Bottom of it is a circle, isn't it? Okay? And again, we'll talk later on about finding the area and volume and stuff of that. But right now, we're just going to identify them. But I don't see anything here. But I've seen stuff before where you might have a cylinder, but it's like slanted like this a little bit. Okay? We wouldn't call that a right cylinder. We would call it something else. Like this one right here. I would call a right. And if you want to put circular, because you could have cylinders that are not circular. So let's put that word in there. I'll just put it right here. Right? Circular. Yeah, if I put a little line right here like this, right, with the box, you would need to say right, and then this is a circle, so you would say right circular cylinder instead of just saying cylinder, okay? All right, let's do another one, another cylinder, but this time it's kind of slanted. See this one? So this is kind of slanted. It's still a cylinder, but it's not a right cylinder. If I would take the middle of the top of this and draw a line perpendicular straight down, it wouldn't even touch the cylinder at all, would it? Okay? So this is not a right cylinder, but we give this a special name. We don't call it a sideways cylinder, and we don't call it slanted. It's a word you probably would never think of, but this is what they call it. They call it oblique. It's an oblique cylinder. So you're going to have an oblique and a hexagon. Okay. All right, listen up. Shh. This word oblique, it just means it's slanted. You ever type on Word or something, you want to make something italics, right? You hit the italics button. Well, in your book, our fonts don't say italics. They actually say oblique. And the kids were like, why in the world does it say oblique? That's right, Casey, you're in there, right? It says oblique. So that means it's slanted. Because isn't that what italics basically does to letters, right? It just kind of slants them a little bit. And so that's the word oblique. So you see it more than just talking about cylinders. It just means it's slanted a little bit. You could have an oblique pyramid. Everybody's listening, right? I need everybody's eyes up here. Thank you. You could have an oblique pyramid, all right? People probably don't build them like that. I don't know. People might think, what's that leaning building in Italy? Leaning Tower of Pisa, okay? It's really not oblique. I think it was built straight up, but I think it's just starting to lean over a little bit, but I don't think it was built to be that way, to be oblique. All right, yes. Is what? You don't have to. I would at least, you can. I mean, I would definitely give it a shot. So far, these have been pretty easy. In a minute, they're going to be a lot. Listen. Candace, please. Bryce, stop. So if you want to try to draw these, you can. They're probably in the book, all right? You can look in the book, but at least know what the word is to what the picture is, all right? Because that's the kind of stuff I'm going to be asking you on a quiz. Let's do a couple more. This is not the best one that I probably could have found, but it's the one I picked, so let's use it. Okay? Now this one right here. Now think of it this way. Let's think of this. Let's think of this thing sitting on that blue triangle right there. All right? So it's sitting on a triangle, and what's happening to all the sides of that triangle? They're going straight up, aren't they? Okay? Again, let's pretend. We got to do a little pretending here. Let's pretend I take that object and I flip it up, right? And it's sitting on that blue triangle. Everybody got me on that? Okay. So if it's sitting on that blue triangle, all the sides go straight up. So that is not a pyramid, okay? And it's not a cylinder. Cylinder we reserve to round objects, okay? What do you think we're going to call this? We do call it a prism. Very good. All right, so we call this, I would call this a right because the sides go straight up. It doesn't lean. It's not oblique, okay? The sides go straight up. Now, what kind of base would this have? What's it sitting on? It's sitting on the blue one, which is a what? It's a triangle. The blue one? The blue one is not. Yeah, this one is a little tougher to draw. This is a lot harder to draw. Okay? But if it's... Guys, come on. Listen. Nico, come on. If it's sitting on that blue one right there, that's called the base, right? That's what it's sitting on. And the sides would go straight up. So that if the sides go completely straight up and makes a right angle with the base, we call it a right. And what is the base? What is the shape of the base? Right. So we call it triangular prism. Okay. So when the sides go straight up, all right, there could be all kinds of different prisms. It doesn't just have to be a triangle at the bottom. You could have a square. You could have a rectangle. You could have an octagon. You could have a pentagon at the bottom. And if the sides go straight up and the top is exactly the same as the bottom, we call that thing a prism. Kasir, do you have a question? I thought you were going to ask a good question about this. You don't have a question about that? Do you have your book? No? Do you have your agenda book? Yeah, fill it out. Fill it out first before you give it to me, and then I'll sign it. All right, we got a couple more. This is a right triangular prism. I could put this on a quiz, and I'll say, what is this figure? And you got to tell me. It's a right triangular prism. Okay, that's what we're doing. You were listening quite a bit. Not quite the whole time, because I saw your head down for a couple minutes. But that's better than normal. So I'll take that. All right. Let's do another one. Now we're going to, well, let's see. We might have one normal one before we get to the real weird ones. So, nope. Now we are getting to the weird ones. All right. Now look at this thing. I'll show it to you first, and I'll tell you what the difference is between this. Now look at this thing. On this right here, all the sides are exactly the same. Okay? So they're all triangles. Let's figure out how many sides does this have. I got 1, 2, 3. Is that it? Just 3 sides? Now there's probably one where? Behind it, right, in the back, okay? So there's another triangle back there that would connect from like here to here to here, something like that, okay? So how many sides are there? Or, yeah, we could say sides. But on this thing right here, we don't call it a side. We call it a face, okay? So we call it a face. They're all the same. Now, you're looking at it. You're like, Mr. Hamrick, this one right here and this one right here sure don't look exactly the same. But remember, yeah, it's perspective. Exactly right. She's an art person, okay? It's all about perspective. You're trying to take something that's three-dimensional and put it into a two-dimensional space, all right? So, like this triangle right here looks a lot skinnier than this one. Would you agree? But you have to use your imagination, and these are all exactly the same triangles, okay? If they're all the same triangles, each of those triangles is called the face. So there are actually 4 faces, 4 faces to this. We call these kind of things not this one particular one, but in general. Okay, remember polygons, right? A pentagon is a polygon, right? Because a polygon has many sides. This one has many faces. We call this a polyhedron. Okay, there's the new word for you, hedron. Yeah, we in our accents or whatever, we just say hedron. Okay, but it's probably hedron, but we just say polyhedron, okay? Poly means many, and the hedrons, I don't even know exactly what it means, but I would say it means all the different sides. Push up a what? Worship. No, like polytheism. Polytheism means you worship many gods, okay? So poly can be used for a lot of different things. All right, so this particular one right here, if it has 4 faces, we give it a special word. You would think it would be quadra something, right? Like quadrahedron or something like that. For some reason, they don't use quadra. What do you think they use? You're not answering my question? You got to go to the bathroom? Don't know. Probably just to make it different, because it's not just a line segment. It's a whole shape. Yeah, it's a 3D shape. Yeah, that's the way you could look at it. So each of these sides, if you want to call it that, they just call it a face just to make it a little different. So if you have 4 faces, right, 4 different sides to this, we call this thing a tetrahedron. Everything's going to end with hedron, okay? You just have to know the prefixes. This is the one that's a little bit different, okay? Tetra, that actually means 4, okay? So it's a tetrahedron, all right? Everybody with me on that? So it's a tetrahedron. All right, let's do a couple more of these. I'm not going to, well, we will show you. I'm going to show you a list of all the names of them, but I'm only going to show you pictures of just a handful of them. Yeah, technically you would call this a regular tetrahedron. Yeah, but I'm not going to worry about that right now. But yeah, you could call it a regular tetrahedron. Okay? All right. Everybody got that one? 4. Could you have a 3-sided tetrahedron? You really couldn't, because if you had one here, and then one here, you wouldn't have a bottom to it, right? If you had one here, and a bottom, you wouldn't be able to have that side. So there's really no way to have 3 sides. So 4 is the smallest one. These all have an ending. These all have an ending, okay? Yeah, but a plane isn't, it's not. I'll just say that. Let's keep going. Look at this one. let's see what this one is. Now, all the sides are the same, okay? All the faces, I keep saying sides, I should say faces. All the faces are the same. How many? That's the question. And this is kind of something I could ask you on a quiz, right? I could give you a picture that looks like this, and you got to tell me what it is. All right, how many? First, just tell me how many. 9? Yeah, but that's not really on the outside of it. It's got to just be on the outside of it. Yeah, there's 8 of them, and they're all triangles, aren't they? Do you see 8 of them? You've got this one, that's 1. You got this one, that's 2. But then behind here is 3, and over here is 4. So you got 4 on the top, and then guess what's on the bottom? There's 4 on the bottom. So how many do you have all together? So there's 8 faces. So now, you should probably be able to get this now, because we know the prefix for 8. This is kind of like a semi-normal one, as far as the, tetra is a little weird, because we haven't really done that prefix with tetra before, but we have done this. So what is this? Octagon, right? Or what? Octahedron. Hedron, okay? By the way, it's octa. Everybody see this? It's not octo. A lot of people spelled it wrong when you put octagon. Okay, it's octa as an A, all right? Octahedron. Pretty easy, isn't it? Just see how many sides you have, all right? There's 8 sides, and so you have an octahedron. Now, I would not expect you to draw that. If you're an artist and you want to try it, feel free. But it's probably in the book. I think we got 1 or 2 more. We got 2 more. Look at this one. This is pretty crazy. Almost looks like a soccer ball, but it's not really round. Okay. Yes, fine. Now, I'm not even going to try to count all these. All right. But I believe there's 12. Yeah, I believe there's 12 faces. Okay, good. So there's 12 faces. It's the same prefix. Guys, don't lose me now. Come on, you guys have been doing well. Well, kind of. For this class anyway, you've been doing well. Let's stick with this. We're almost done. There's 12 faces. Do you remember what the prefix for 12 was when we did the polygons? Deca, but it's not a gon, it's a hedron, right? So that would be a dodecahedron. That's a crazy name, isn't it? All right. So John, if you keep having kids, you can name your 4th one dodecahedron or or whatever. Okay, dodecahedron. That's right there. Okay. Well, your dad's in-laws, your mom's family had 12, right? They have 12, so. There's one more. Okay, so this is dodecahedron. Don't worry about drawing it. Just know if it has 12 faces, that's what the name of it is. Last one. This is really crazy. It's very colorful, though. I don't know if you could count them or not. There's a lot behind it that you'd have to count. But there are 20 faces to this one.
20?
Yeah.
20. I just counted all of them. What's it called? It's a 20 hedron. No, it's called a...
Here it is. It's Icosahedron or Icosahedron. I'm not really sure how people pronounce it. But Icosahedron. Why are people walking around? John, that could wait. Logan, stop. I'm trying to get everybody settled down. My goodness. No more getting up unless I tell you you can get up. So this is called an icosahedron. All right? It's got 20 faces. We'll stop right there with all these pictures. That's an icosahedron. You got to remember those prefixes. If you can remember hedron, this shouldn't be too bad. You do have homework.
I didn't get the last one.
It's right there in front of you. It's icosahedron. I just said it 10 times. All right, here's your homework. It's section 1.7. Page 42, 43. And you're doing a 1 to 32. Yeah, but a lot of this, you're not really doing any math. All you're doing is just answering some questions about this stuff, okay?
Thank you.
I know it's a lot of questions, but they're not hard questions. They're pretty easy. That is your homework.